Chapter 3, Lesson 1 of Geometry, and I want to do this one example because it ties together all of the different things that we've been working with these angles. And again, the idea or the course behind geometry, the focus is being able to look at a diagram and determine the different relationships that are in the diagram, thus allowing me to calculate some variables, can calculate some measures of angles, or maybe even prove some theorems and whatnot. So just as a reminder, some of the things we know, or some of the things that we've learned so far, we know that vertical angles are congruent. We learned that in an earlier lesson. And in this lesson, we learned that alternate exteriors are congruent, and we also learned that alternate interiors are congruent. And we also learned that corresponding angles are congruent. So we have four different relationships between pairs of angles which allow us to write an equation whereas one angle is equal to another. We also learned in this lesson that same side interiors are supplementary, so if I add the two angles together, they're going to add up to 180, another equation. We also know that same side exteriors are going to be supplementary and add up to 180. We also know that using angle addition postulate, that if we add two angles together that form a line, those also are going to equal 180. So I have 7 different ways here that allow me to write 7 different equations, and using those I should be able to solve then or determine the value of any of the equations or any of the angles in this diagram. Now, I may see things some way, you may see things another way, but any way works because they all get us the measure of the angles. So I'll just give you some way that you can kind of look and work your way around this diagram. Now, it's important to notice here that we have multiple diagrams going on in this picture because I have line A here and line B that are parallel, and line C could be a transversal. So if I ignore line D for the moment, then I have these 8 angles that are formed by using lines A and B as parallel and line C as its transversal. However, if I use let me go back here. If I use line D as my transversal, still using A and B, then I have these 8 angles that are also formed, I don't know how to count, 5, 6, 7, 8, which also are going to be able to be used using parallel. But I want you to notice something else, is that D and C are parallel. So that means if I use line A as my transversal, then I have these 8 angles. Okay, so I have a diagram. If you kind of turn your head sideways, that might help you see that a little bit better. And also, if I use C and D as parallel, I have line B, which would be the transversal, creating these 8 angles with 2 lines that are parallel. So there's multiple, not only are there multiple theorems and postulates that I can use in here, there's also multiple ways to look at the diagram. So including all of those together is going to make determining the values of these angles possible. So let's go ahead and take a look at it. And again, you may see this a little bit differently as I do, and that's okay as long as you're dealing with parallel lines and transversal. How you determine the value doesn't really matter. So the one that sticks out to me most right away is that angle 8 here. Angle 8 here is vertical to this one that they give us, so I'm saying angle 8 is going to be 50. I then notice that angle 6 is well, one of two things. It corresponding to angle 8 if you look at it sideways, or it's also alternate interior to this angle 50. So angle 6 is going to be 50 degrees as well. Now, if I look at 6 and 7 together, 6 and 7 are same side interiors, so they're going to add up to 180. So 150 or 180 minus 50 is going to make this 130. The other way to look at that one could be, well, angle 50 and angle 7 added together form a straight line, so they're going to add up to 180, so I could determine it that way as well. Let's see, what else can I do here? Well, now that I know angle 7 and angle 2 here are alternate interiors, which means they're equal. So that means angle 2 is going to be 130 degrees. Then angle 2 and angle 4 are alternate interior. So alternate interiors are equal, so that one's going to be 130. Now 3 and 4 are vertical, and I know verticals are equal, so 3 is going to equal 130. Now I could do, let's see, well, a number of ways to look at angle 1 here. 50 and angle 1 are corresponding, and correspondings are equal, so I know that angle 1 is 50. Another way to do it would be angle 1 and angle 3 are same side interior, meaning they add up to 180, so I could subtract 130 from 180 to get the 150 for that. That's another way I could calculate that. Um, let's see. Well, that's pretty good. But you may have seen something else there. Now that I know angle 1 and 5 are vertical. Verticals are equal, that I know. So angle 5 would be 50. So you can see by just knowing the measure of one angle and using all of those relationships that we know, I'm able to determine the value of any angle in the diagram. I could find the other ones that aren't marked too, because again, all you need is one measurement, and then based upon these 7 theorems and postulates as we've learned so far, we're able to determine the value of any angle in that diagram.